Now look at this problem. We have been asked to find the last digit of 7 raised to power 25. Without understanding the cyclicity of the powers, the last digits that they repeat in cycles, this question is actually unsolvable in the given amount of time, in 1 minute. Okay, but once we understand that concept, we can simply see that let us just compute the powers of 7. So I'm just computing what the last digits of these would be. Okay, either you can remember this, okay, we have it here, so you can remember this, or right here we have it, so either you can remember this or you can just compute it on the fly. There is no need for remembering. This can be done in a very short amount of time. Because we are only concerned with the last digits, we don't have to compute this fully. We only are interested in the last digits. So this will be 7 1, so this will be, last digit would be 7. For 7 squared, 7 7s are 49, so last digit would be 9. I'm not worried about rest of the number, I don't even compute it. And for this, the last digit would be 3. For fourth power, the last digit would be 7th is a 21, so then there would be something, and then the last digit would be 1. What about afterwards? 7 raised to power 5, it would be something, and then 7 1s are 7. Okay, so this is 7 1s are 7. I just write it here. Okay, so same thing I did here. 7 3s are 21. I just wrote the last digit here. So here we have this, which is the last digit as 7, and here also our last digit was 7. So now I can understand that the last digits would start repeating after the 4 terms. So after I have these 4 terms, the last digit would start repeating. So now I need to find out how many complete group of 4s I can make in this 25. Okay, so 1 2 3 4, so this is the complete group. After this, the fifth would be same as the first one. So how many complete groups of 4 are there in 25? I can say that this is equal to 6 into 4 plus 1. So there are 6 complete groups, which means that 7 raised to power 24 this would be similar to 7 raised to power 4 in terms of cyclicity, which means that the last digit would actually be equal to 1 for 7 raised to power 24. 7 raised to power 25 would be similar to 7 raised to power 5, right? What is this? 7 raised to power 25 would come out after 7 raised to power 24. 7 raised to power 5 comes after 7 raised to power 4. So 7 raised to power 25 would be similar to 7 raised to power 5, which has the last digit of 7. Okay, that is our answer. Okay, so this was very simple question, provided you understood that concept of cyclicity of the last digit of powers of numbers. Now here is another example. Here we have been asked to find the last digit of the sum of 2 powers. Okay, we don't need to really compute the entire powers. Why? Because we are only interested in the last digit. So what would be the last digit of 2 raised to power 5? The last digit for 2 raised to power 5, we know that 2 raised to power 5 repeats after 4. Okay, so after 4, the fifth is same as 1. So this 5 would be same as 2 raised to power 1. So the last digit would be 2. Plus this we know repeats after every 2. So again, even for this, the last digit would be, so there will be some number and then 2. Similarly here, there will be some digits and then this 5. Okay, because for 9, the repetition is after every 2 digits. Okay, after every 2 powers there is a repetition. So there would be 1 2, which will in the same group, then 3 4, which will in the same group, the powers, right? 9 raised to power 1, 9 raised to power 2, 9 raised to power 3, 9 raised to power 4 would be in the same group. Then 9 raised to power 5 would actually be similar to 9 raised to power 1. Okay, it would be same as 9 raised to power 1, and of course 9 raised to power 1, the last digit is 9, so 9 raised to power 5, the last digit should also be equal to 9. Now if you compute this, last digit would come out to be 9 plus 2, which is 11, so 1, and then there would be some other digits which we are not even worried about. We are only worried about the last digit. Now from here on, another thing that we can do is that we can also find what would be the last digit of multiplication. So if you have been asked what would be the last digit of multiplication of these two numbers, we can even find that, right? We know that the last digit of 9 raised to power 5 is actually equal to 9, And we know that the last digit of 2 raised to power 5 is actually equal to 2. And if you multiply them together, the last digit would definitely be 8. Okay, and we are not even worried about the last number. So not only can we find the last digits of the